Function parameters with examples. In Python, there are several types of function parameters that allow you to pass arguments to functions in different ways. Understanding these different types of function parameters help you write more flexible and powerful functions. Here are the main types of function parameters. First, positional parameters. Positional parameters are the most common type of parameters in Python functions. They are defined in the order they appear in the function's parameter list. When calling the function, you must provide arguments in the same order. Example: output. Explanation. In this example, we have a function greet that takes two positional parameters, name and greeting. When we call the function with greet, Arun, hello, the arguments Arun and hello are passed to the corresponding parameters, name and greeting. The function then prints hello Arun. Second, default parameters. Default parameters have predefined values in the function signature. If a value is not provided for a default parameter during the function call, the default value is used. Example: output. Explanation. In this example, we have a function greet with a default parameter greeting set to hello. When we call the function with only greet Arun, the value hello is used for the greeting parameter, as no value is provided explicitly. However, when we call greet Bobby hi, the provided value hi overrides the default value and the function prints hi Bob. Third, keyboard parameters. Keyboard parameters are passed to functions using the parameter names followed by an equal sign and the corresponding value. They allow you to specify arguments in any order, regardless of the parameter order in the function signature. Output. Explanation. In this example, we call the greet function using keyword arguments where the argument names are provided along with their values. The order of the argument does not matter in this case. So when we call greet, greeting is equal to hi, name is equal to Arun. The function correctly maps the values to the corresponding parameters and it prints hi Arun. Fourth, variable length keyword parameters. Quarks. Output. Explanation. In this example, we define the function print person info with quarks, which allows it to accept a variable number of keyword arguments. The function then iterates through the keyword arguments, which are stored as a dictionary, and prints the key value pairs. When we call print person info, name is equal to Arun, age is equal to 30, city is equal to New Delhi. The function prints the provided information for name, age and city. Fifth, variable length positional parameters. Args. The args syntax allows a function to accept a variable number of positional arguments. It collects the extra positional arguments as a tuple inside the function. Output. Explanation. In this example, we define the add function with args, which allows it to accept a variable number of positional arguments. The function adds up all the arguments passed to it and returns the total. When we call add 1, 2, 3, the function adds 1, 2, 3, resulting in an output of 6. Similarly, when we call add 10, 20, 30, 40, 50, the function adds all 5 values and returns the total, which is 150. Combining parameter types. You can use a combination of all these parameter types in a single function to create powerful and flexible function definitions. Example. Explanation. In this example, we have a function, custom function, with a combination of different parameter types. It has a positional parameter a default parameter b with a default value of 10, a variable length positional parameter args, a keyword only parameter c with a default value of 20, a variable length keyword parameter quarks. While I have not provided a specific example for this function, it demonstrates how you can use various parameter types together to create more flexible and versatile functions. By leveraging these different types of function parameters, you can write more powerful and adaptable functions that cater to various use cases and scenarios in your Python code. Case 1. Calling a function twice, one after the other. Output. Explanation. In this example, we define a function called print twice message, which takes a single parameter message. Inside the function, we print the message twice, each on a separate line. When we call the function for the first time with print twice hello world, the function prints hello world twice as shown in the output. The function is executed and the message is printed twice on separate lines. After that, we call the function again with print twice. Python is fun. Once again, the function is executed and the provided message Python is fun is printed twice, one after the other on a separate lines. It's essential to understand that each function call is independent of the others. Calling a function twice in a row does not affect the execution of the function during subsequent calls. The function's behavior remains the same each time it is called, and it can be called with different arguments or the same arguments as needed. In this example, the function print twice demonstrates how a simple function can be called multiple times with different input messages, producing the same behavior each time it is called. This illustrates the reusability of functions, where you can call them multiple times throughout your code to perform the same task with different inputs. Case 2. Calculate the area of a rhombus. To calculate the area of a rhombus, you need to know the length of its diagonals. The formula to find the area of a rhombus is diagonal 1 asterisk diagonal 2 divided by 2. Example. Let's create a function rhombus area that takes the length of the two diagonals as parameters and calculates the area of the rhombus using the given formula. Explanation. In this example, we define the function rhombus area diagonal 1, diagonal 2 that calculates the area of the rhombus using the formula diagonal 1 asterisk diagonal 2 divided by 2. We then call the function with diagonal 1 is equal to 8 and diagonal 2 is equal to 10. The function computes the area as 8 asterisk 10 divided by 2, which results in 40.0. The function rhombus area allows us to calculate the area of a rhombus easily by providing the lengths of its diagonals as input arguments. It demonstrates how functions can encapsulate complex calculations, making the code more organized, reusable, and easier to understand. Case 3. Calculate the area of a circle. To calculate the area of a circle, you need to know the radius of the circle. The formula to find the area of a circle is pi multiplied by radius square 2, where pi is a mathematical constant approximately equal to 3.14159. Example. Let's create a function circle area that takes the radius of the circle as a parameter and calculates the area using the given formula. Explanation. In this example, we first import the math module to access the constant value of pi. Then we define the function circle area radius that calculates the area of the circle using the formula math pi asterisk radius asterisk asterisk 2. We then call the function with radius is equal to 5. The function computes the area as pi asterisk 5 square 2, which results in approximately 78.54. Finally, we print the result using formatted string literals f string and the 2f format specifier to display the calculated area rounded to 2 decimal places. The function circle area demonstrates how to calculate the area of a circle using its radius as input by encapsulating the formula inside a function. We can easily calculate the area for different circle radii, promoting code reusability and maintainability. The math module provides the accurate value of pi, ensuring precise calculations for the circle's area.